Hello viewers, my name is Dr. Ajay from the Department of ECE, Associate Professor from IARE Engineering College, Hyderabad. Today's topic is array with n isotropic point sources of equal amplitude and spacing. Both the cases, that is broadside array and end-fire array, we are going to consider. So this is the topic related to the course antennas, waves and propagation. So today's topic is array with n isotropic point sources of equal amplitude and spacing. So the two cases may be broadside array and end-fire array. So let us start our session today. So as we have seen in the earlier video, we will continue from the earlier video. There is the linear array with n isotropic point sources of equal amplitude and spacing. So we got the final expression as Et is equal to E naught into sin n psi by 2 by sin psi by 2 angle pi. So Et is equal to E naught into sin n psi by 2 by sin psi by 2 angle pi. So where pi is taken as tan inverse of tan b by a, that is n minus 1 into psi by 2. So from this expression, we are going to extend this for n isotropic point sources in the broadside array case. So here pi is taken as here angle pi is taken as n minus 1 by 2 into psi is equal to pi. So this is the equation of total far field pattern of linear array of n isotropic point source, as source 1 is as a reference point for phase. So in case the reference point is shifted to the center of the array from the source or origin of the coordinate, then the phase angle is automatically eliminated and the equation 25 reduces to n minus 1 by 2 into psi is equal to psi. So here we have derived the expression for the case where 1 and 2 are separated. So here we have taken this point as origin 1 and 2 and 3. Right? So suppose source 1 is taken as the reference point for the phase. So in case the reference point is shifted to the center of the array from the source or origin of the coordinate, then the phase angle is automatically eliminated and the equation 25 reduces to n minus 1 by 2 into psi is equal to pi. So Et is equal to the final expression which we got is a linear array with anisotropic point sources of equal amplitude and spacing. So Et is equal to E naught into sin n psi by 2 by sin psi by 2. So in equation 26, E naught represents the amplitude of the individual source pattern or on the secondary pattern or array factor. So here in equation 26, E naught will represent the individual source pattern or primary pattern and the secondary pattern or array factor. So sin n psi by 2 by sin psi by 2. So sin n psi by 2 by sin psi by 2 is the secondary pattern, or which we simply call it as an array factor. So sin n psi by 2 by sin psi by 2 is known as the array factor. Now let us come to the case of broadside array, that is array with n isotropic point sources of equal amplitude and spacing, and this is the broadside case. So an array is said to be broadside array if the phase angle is such that it makes maximum radiation perpendicular to the line of the array, that is 90 and 270. So in broadside array, sources are in phase, that is alpha is equal to 0 and psi is equal to 0 for maximum must be satisfied. So that means in the broadside array, so you can see here, this is the line of array. All the elements are arranged linearly. All the elements are arranged linearly and with equal distance. And here the maximum radiation is perpendicular. That means this is the perpendicular, this is 0, and this is 90, this is 180, and this is 270. So perpendicular to the line of the array. So this is the line of the array. This is the line of the array. For this line, the regression pattern is maximum perpendicular to the line of the array. Then the array is said to be the broadside array. Then the array is said to be the broadside array. So as we have seen that from the expression psi is equal to beta d cos theta plus alpha. Here the phase angle is assumed as 0. That means in case of broadside array, the phase angle, that is the phase difference between the elements is assumed as 0. So then psi is equal to beta d cos theta plus 0. So based upon this, beta d cos theta is equal to 0, substitute alpha is equal to 0. If you simplify beta d cos theta is equal to 0, you will get cos theta is equal to 0. So if you simplify by the trigonometric function cos theta is equal to 0, you will get theta is equal to 90 degrees or 270 degrees. Theta is equal to 90 degrees or 270 degrees. It means that the maximum radiation will be in the directions of 90 and 270. The maximum radiation pattern when arranged in the broadside case, the radiation will be maximum in the angles of 90 and 270 degrees. So let us find out from the basic expression of ET. ET is equal to, we know that ET is equal to E naught into sin n psi by 2 by sin psi by 2. So this is the final expression which we got from the multiplication pattern. So from the multiplication pattern, as we have derived the expression for linear array, we got the expression as ET is equal to E naught sin n psi by 2 by sin psi by 2. So we know that to draw the radiation pattern, we need to know the maximum direction, we need to know the minimum direction, we need to know the beam width between the first nulls or half power beam width. So based upon these parameters, we are going to draw the radiation pattern. And to draw the radiation pattern, first we want the total field strength produced by all the individual elements of the broadside array. So what is the total elements? What is the total field strength produced by all the individual elements in a broadside array? We can simplify. We got the expression as ET is equal to E naught sin n psi by 2 by sin psi by 2. So if we want to find out the directions of pattern maxima, so what is the maximum value of sin? It is 1. The maximum value of sin is equal to 1. So here you can see this is the LHS and this is the RHS. That is the right hand side and this is the LHS. So the RHS, LHS is maximum. The ET will be maximum when the sine function is maximum. Right? ET will be maximum when the sine function is maximum. And when the sine function is maximum, when this is equal to 1. When this is equal to 1. So under this condition, if we equate sin n psi by 2 is equal to 1, sin n psi by 2 equal to 1, you will get n psi by 2 is equal to plus or minus 2n plus 1 into pi by 2. So n psi by 2 is equal to plus or minus 2n plus 1 into pi by 2. So this is the solution. So this is the trigonometric solution for this expression. N psi by 2. For if n psi by 2 will be maximum at 1, the maximum value is 1. So for this 1, n psi by 2 is equal to 1. The trigonometric solution, it is given by n psi by 2 is equal to plus or minus 2n plus 1 into pi by 2. Plus or minus 2n plus 1 into pi by 2, where n is the number of sources. Now if we substitute n is equal to 0, then what we will get? N psi by 2 is equal to, where n is equal to 1, 2, 3, 4 are the number of elements correspond to the major lobe maxima. Major lobe maxima. So this is the major lobe, this is the minor lobe. So this is the known as major lobe maxima. Major lobe maxima is this one. And this is known as the minor lobe maxima. Minor lobe maxima. And this portion is known as minor lobe minima. This portion is known as minor lobe minima. So like this, you need to identify 4 parameters. That is a major lobe maxima and major lobe minima, minor lobe maxima and minor lobe minima to draw the radiation pattern. So identify these parameters to draw the radiation pattern. So what we need to do is, first you take the electric field strength expression, find out the maximum value by equating the sine value equal to 1. First, and then you find out the solution from the trigonometric solution for the above expression. Now let us assume n is equal to 0 corresponds to the major lobe maxima. So as n is equal to 0 corresponds to the major lobe maxima, if you substitute here n is equal to 0 in this expression, substitute here n is equal to 0. See here in this expression, if you substitute n is equal to 0, what you will get? N psi by 2 is equal to plus or minus pi by 2. We will get plus or minus pi by 2. So based upon this expression, you can further simplify. Psi by 2 is equal to plus or minus 2n plus 1 into pi by 2 into 1 by n. See the above expression, we are going to find out the value of psi. From this value, you are going to find out the psi. Take this psi as common and n by 2 to the, you take this n by 2 to the RHS. If you further simplification, mathematical simplification, you will get psi is equal to plus or minus 2n plus 1 into pi by n. So psi is equal to plus or minus 2n plus 1 into pi by n. And where we know that psi is equal to beta d cos theta max plus alpha is equal to plus or minus 2n plus 1 into pi by n. So we know that psi is equal to beta d cos theta plus alpha. So psi is equal to beta d cos theta plus alpha. So here theta is the maximum lobe. That means the major lobe maxima. That is the major lobe maxima. It is indicated as beta d cos theta max. Now in this expression, if we substitute n as the final expression, we find out the value of theta. So if you simplify the mathematical analysis, take this alpha to the RHS, you will get minus alpha. Take alpha to the RHS, you will get minus alpha. So beta d cos theta max min is equal to plus or minus 2n plus 1 into pi by n minus alpha. And if you want to find out the theta max min, you will get 1 by beta d. You will get 1 by beta d here. So cos theta max minor is equal to 1 by beta d into plus or minus 2n plus 1 into pi by n minus alpha. So this is just for mathematical simplification. So where cos theta max minor is equal to cos inverse of 1 by beta d plus or minus 2n plus 1 into pi by n minus alpha. So overall you will get minor lobe maxima is equal to cos inverse of 1 by beta d into plus or minus 2n plus 1 into pi by n minus alpha. So this is the final expression to find out the maximum direction of maximum of major lobe. Now theta max is a minor lobe maxima. So for a broadside array, alpha is equal to 0 from equation 27. Okay. So if we want to find out the minor lobe maxima, maximum is the minor lobe maxima. Substitute cos inverse of 1 by beta d into alpha is equal to 0. So in this expression, if alpha is equal to 0, you will get minor lobe maxima. Right? So if we substitute alpha is equal to 0, this expression is valid for major lobe maxima. This expression is valid for major lobe maxima. And from this expression, if alpha is equal to 0, the expression can be modified as minor lobe maxima. The expression can be modified as minor lobe maxima. See here, we are indicated as minor lobe maxima. And this is the major. This is not minor. This is major. Major lobe maxima. Right, so major lobe maxima. See here, what is the difference between major lobe maxima and minor lobe maxima? So if you draw the regression pattern, this is the major lobe on the maximum point. This is the minor lobe maxima. Minor lobe of the maximum. And if you take a minor lobes, this point, these are known as small minor lobes. This is known as minor lobe maxima. Minor lobe maxima. And this portion we call it as minor lobe minima. Minor lobe minima. Right? So this equation 27 represents the major lobe maxima. If alpha is equal to 0, we will get the minor lobe maxima. So to identify the minor lobe maxima, substitute alpha is equal to 0. By substituting alpha is equal to 0, you will get cos inverse of 1 by beta d into plus or minus 2n plus 1 into pi by n. Plus or minus 2n plus 1 by n into pi. So this is equal to cos inverse of lambda by 2 pi d into plus or minus 2n plus 1 by n into pi. So overall, if you simplify mathematical analysis, you will get minor lobe maxima as cos inverse of plus or minus 2n plus 1 into lambda by 2nd. 2nd. Now let us take a special case. Let us take a special case where the number of sources are 4. Where the number of sources are 4. That means we have, if in a broadside array, there are 4 number of sources, isotropic sources. And the distance between the elements is taken as lambda by 2. See here, you can see here, these are 4 sources, 1, 2, 3 and 4. And these are separated by the distance lambda by 2. These are separated by distance lambda by 2 here. All these elements are separated by distance of lambda by 2. And alpha, the phase difference between the 2 elements is taken as 0. So under these conditions, let us determine the major lobe maxima as we can find out as cos inverse of plus or minus c here. You can substitute this formula. In this formula, you substitute d is equal to lambda by 2. In this formula, you substitute d is equal to lambda by 2. And n is equal to 4. And alpha is equal to 0. substitute these expressions in this equation 28 or equation 27, you can find out the minor lobe and major lobe maxima. So the minor lobe maxima will get 2n plus 1 by 4. And if you assume this value, if capital N is equal to 1, you will get a minor lobe maxima as plus or minus 0.75. So the minor lobe maxima is equal to plus or minus 0.75. So the theta max value will be in the direction of plus or minus 41.4 or plus or minus 138.6. So the minor lobe maxima will be equivalent to 41.4 degrees or plus or minus 138.6 degrees. So this is plus or minus plus 41.4 plus 138.6 plus 41.4 and minus 138.6 are the 4 minor lobe maxima of the array of 4 isotropic sources in phase spaced lambda by 2 apart. Right? So based upon the expression of Et is equal to sin n psi by 2 by sin psi by 2, we can determine all the major lobe maxima and minor lobe maxima. So here from this expression you can also find out that no other maxima exists if n is equal to 2. Right? So why? Because if you substitute here n is equal to 2, you will get the value as greater than 1. If you substitute here n as 2 here, you will get 2 into 2, 4, 4 plus 1, 5, you will get 5 by 4. So cos inverse of 5 by 4 means cos inverse of, you will get 1.2 something. Cos inverse of 1.2 which does not exist. So cos inverse of 1.2 does not exist. That means only n is equal to 1 is the radiation pattern of maximum radiation pattern where the field strength is maximum. So based upon this, no other maxima exists because for n is equal to 2, theta max min is equal to plus 5 by 4, that is greater than 1, whereas cosine function is always less than 1. So major lobe maxima occurs when psi is equal to 0, which gives theta is equal to 90 or 270. Right? So psi is equal to 0. So the major lobe maxima occurs at 90 or 270, and these are known as minor lobe maxima. Minor lobe maxima and major lobe maxima are 90 and 270. It means that, see here, if you draw the radiation pattern, this is 90 and this is 270. These are known as major lobe maxima. And the minor lobe maxima occurs at plus 41.4 here and plus 138.6 here. These are known as the direction of maximum radiation for a broadside array. See here we have indicated the broadside array as what we got the major lobe maxima and minor lobe maxima. So the major lobe maxima is 90 and 270, and these are the minor lobe. These are the minor lobe maxima point. So the minor lobe maxima point are in the direction of plus 41.4 plus 138.6. Right? The minor lobe maxima in the direction of plus 41.4 minus 41.4 plus 138.6. And the other things are nulls 60, 120, and minus 60 and minus 120 are nulls. So we can draw the radiation pattern just by assuming as theta is equal to 0 here. This is 90, this is 180, and this is 270 degrees. So from the data what we got, 90 or 270 and these two things, minor lobe maxima. So we are going to draw the radiation pattern for a broadside array, which is the case for with n isotropic point sources of equal amplitude and spacing. Now the direction of pattern minima. Now let us find out the direction of a pattern minima. So we have drawn the radiation pattern for major lobe maxima and minor lobe maxima. We took two considerations. One is major lobe maxima, the other one is minor lobe maxima. Now let us find out the direction of pattern minima. So according to the directions of minima of minor lobes in the array of n isotropic sources of equal amplitude and phase is given by, now let us just take again the same expression, that is Et is equal to E naught into sin n psi by 2 by sin psi by 2 is equal to 0. That is sin n psi by 2 is equal to 0 provided sin psi by 2 is equal to 0. So we know that to find out the minimum value of sine function is 0. So in the previous case we have seen that the maximum value of sine is 1. Here the minimum, to find out the direction of pattern minima, let us equate the expression to 0. Why? Because the minimum value of sine function is 0. So sin n psi by 2 is 0 provided sin psi by 2 is not equal to 0. If sin n psi by 2 is equal to 0, the trigonometric solution for this expression sin n psi by 2 is 0, it is given by n psi by 2 is equal to plus or minus n pi. This is the trigonometric solution for n psi by 2 is equal to plus or minus n pi, where psi is given as plus or minus 2 n pi by n, where psi is equal to plus or minus 2 n pi by n. So based upon this term, we are going to find out the psi means beta d cos theta plus alpha, right? Beta d cos theta plus alpha. So beta d cos theta, why we are going to find out minor lobe minima. So we have indicated as this indicates, that is min of minor. So min of minor means minor lobe minima. Minor lobe minima plus alpha is equal to plus or minus 2 n pi by n. Now minor lobe minima, from this expression you bring this beta d to the RHS side, alpha becomes minus alpha, this beta d becomes 1 by beta d. This beta d becomes, if you take to the RHS side, right hand side, it becomes 1 by beta d. So by simple mathematical analysis, if you find out theta min minor, you will get cos inverse of 1 by beta d plus or minus 2 n pi by n minus alpha. So 1 by beta d into plus or minus 2 n pi by n minus alpha. So now from this expression, let us determine minor lobe minima by assumption of same, like d is equal to lambda by 2 and n is equal to 4. That means to find out the minor lobe minima, let us assume a special case by considering 4 isotropic sources as n is equal to 4, and these 4 sources are separated by distance of d is equal to lambda by 2. D is equal to lambda by 2. So for broadside case, alpha is equal to 0. So if you substitute alpha is equal to 0, you will get this expression, that is cos inverse of 1 by beta d plus or minus 2 n pi by n, plus or minus 2 n pi by n. So that equal to cos inverse of lambda by 2 pi d into plus or minus 2 n pi by n. Why? Because beta is equal to 2 pi by lambda. We know that beta is equal to 2 pi by lambda. Substitute beta is equal to 2 pi by lambda. You will get lambda by 2 pi d plus or minus 2 n pi by n. So if you further simplify this, you will get cos inverse of 2 n lambda by 2 n d. So theta min minor lobe minima is equal to, final expression we got is cos inverse of plus or minus n lambda by nd, plus or minus n lambda by nd. Now for this case, let us assume a special case, that is assume there are four sources in broadside case, and these are separated by d is equal to lambda by 2 and alpha is equal to 0. So if you substitute these parameters in this expression, equation 30, you will get substitute n is equal to 4 here and d is equal to lambda by 2 here. If you substitute, you will get cos inverse of plus or minus 1 by 2. So the minor lobe minima of 1 by 2 is equal to, you will get cos 60 and 120. See here, we will get minor lobe minima is equal to plus or minus 60 degrees, comma, plus or minus 120 degrees. So the minor lobe minima is equal to cos inverse of plus or minus 2 by 4 into lambda if n is equal to 2. Suppose if you take n is equal to 2, if you take n is equal to 2, for this case, in this case we assumed n as 1. If you take n is equal to 2, you will get 0, 180 degrees, plus or minus 0, 180 degrees. That means you can see from these figures that the minor lobe minima are in the direction of 60 and 120, and also the minor lobe minima are in the direction of 0 and 180. So minor lobe minima are in the direction of 60 plus or minus 60 and plus or minus 120 and 0, 180 degrees. So these are the 6 minor lobe minima. That means 0 degrees, 60 degrees, 120 degrees, 180 degrees, minus 60 degrees, minus 120 degrees are the 6 minor lobes minima of the array of 4 isotropic sources in phase, spaced lambda by 2 apart. Right? So if you draw the regression pattern for this, the minor lobe. So these are known as minor lobes. So in the direction of 0, this is 90, this is 180, and this is 270. Right? So here in the direction of 0, this is the direction of 0, this is minor lobe. In the direction of 60, this is 60. In the direction of 120, in the direction of 180, in the direction of, you will get like this. So you will get total you will get 6 minor lobe minima, right? So you can see here, this is direction of 0 degrees, this is 180, this is 1, and this is 60, this is 120, this is minus 60, this is minus 120, right? So this is 0 degrees and this is 180 degrees. So like this, you can draw the minor lobe minima, 6 minor lobe minima of array of 4 isotropic sources in phase spaced lambda by 2 apart. Now let us find out the beam width of the major lobe. Let us find out the beam width of the major lobe. So to find out the beam width of the major lobe, it is necessary to find out the angle between the first nulls. What is the angle between the first nulls? It is double the angle between the first null and the major lobe maxima directions. Right? So if you want to find out the angle beam width between the major lobe, you can see here. Suppose let us say this is the major lobe. The angle between the first nulls, that means if these are known as first nulls. If these are known as first nulls, the angle between the first nulls is known as the beam width between the first nulls. So this is the beam width between the first nulls, BWFN. This is BWFN. So the angle between the first nulls is known as the beam width of the major lobe. And in another way, we can also find out the beam width between the first nulls by taking only half of the major lobe of the angle. That means you can see here, these are the first nulls. Double the angle between the first null. So if you take this as a first null, right? And this is the, so this is half. This is half portion and this is half portion. That means, so double the angle. That means that double the angle between the first null and the major lobe maxima. So this is the major lobe maxima and this is the first null. So this is the first null. So this is the first null. So this is also one method to determine the beam width of the major lobe. Right? So the angle between the first nulls is taken as the beam width, or in another way, you can also take the beam width between the first null and the major lobe maxima. On the major lobe maxima, that angle we call it as the beam width. Right? So the beam width of the major lobe is usually small, hence the complementary angle gamma will be a better deal. Right? So the beam width of the major lobe is given by 2 into angle between the first null and the maximum of the major lobe. So this angle, let us assume as gamma. Beam width between the first null and the major lobe maxima is assumed as gamma. 2 times the gamma is nothing but the beam width between the first nulls. So 2 times the gamma value is nothing but the beam width between the first nulls is equal to 2 into gamma. So from equation 30, you can find out, let us find out the beam width from the expression. Theta min, we know that cos inverse of plus or minus n lambda by n d. Theta min is equal to cos inverse of plus or minus n lambda by n d. And gamma is equal to 90 minus theta. Right? The total value is theta. So this value can be written as 90 minus theta. This value is nothing but 90 minus theta. So by substituting theta min as 90 minus theta m, 90 minus theta min is equal to gamma. Right? So we know that gamma is equal to 90 minus theta m, or 90 minus gamma is equal to theta m. Right? Now substitute this theta m as 90 minus gamma. So this value is substituted here, theta min. You will get 90 minus gamma is equal to plus or minus cos inverse of plus or minus n lambda by n d. That equal to cos of 90 minus gamma is equal to sin gamma is equal to plus or minus n lambda by n d. So if you substitute here cos 90 minus gamma is equal to sin gamma. You know that cos 90 is equal to sin theta. So cos 90 minus theta is equal to sin theta. That means sin gamma is equal to plus or minus n lambda by n d. This is the expression we got from the simplifying mathematically. So if gamma is assumed as very small, if this gamma value is assumed as very small value, then sin gamma is equal to gamma. Right? So if we assume this gamma value is very small, then sin gamma will be equivalent to gamma. So overall, gamma is equivalent to n lambda by n d. Gamma is equivalent to plus or minus n lambda. See here, you can see here, gamma is equal to plus or minus n lambda by nd. If sin gamma is equal to gamma, another condition, gamma is very small. Gamma is very small. Now let us find out the first nulls and second nulls. The first null will occur when n is equal to 1. Now let us say capital N is equal to 1. That means the nulls, where actually nulls will occur. At what angle? At what angle the nulls will occur? So we assume n equal to 1. You will get gamma 1 is equal to plus or minus lambda by nd. And 2 lambda by nd you will get. So BWFN is equal to 2 lambda by nd. So if we assume the broadside array is very large, that means n is greater than, or the number of elements is greater than 20 or 40 in an array. Under this condition, n lambda is far greater than nd, then 2 gamma 1 is equal to 2 lambda by nd. So 2 gamma 1 is equal to 2 lambda by nd. Or simply nd is equal to L. So nd is nothing but the length of the array, it's simplified as nd. L is nothing but the length, the total length of the array. The total length of any array is indicated as capital L is equal to total length of the array in meter is equal to n minus 1 into d. If n is large, we can write it as nd. If n is large, we can write it as nd. The common expression for L is n minus 1 into d. If the number of sources are very large, then we can write it as simply as nd. So under this condition, 2 gamma 1 is equal to 2 lambda by L. So under this condition, 2 gamma 1 is equal to 2 lambda by L. If we bring this lambda to the denominator, you will get L by lambda. That means 2 into 57.3 by L by lambda. So 2 into 57.3 whole divided by L by lambda you will get. So 2 gamma 1 is equal to, you will get 2 into 57.3. If you multiply the numerator, you will get 114.6. So 114.6 degrees is equal to BWFN, that is L by lambda, that is equation 34. And we know that half power beam width is nothing but it is half of the beam width value. So whatever the beam width means, complete angle of the measure lobe. Half power beam width, half angle of the measure lobe. So that is half angle of the beam width angle, we get the half power beam width value. So the half power beam width value is equal to BWFN by 2. So overall you will get, if we multiply this by 2, you will get 57.3 by L by lambda. So 57.3 by L by lambda. So 114.6 by L by lambda, if you simplify this 1 by 2, you will get this value. If you simplify by 2, you will get 57.3 into L by lambda. So overall, the array with the n isotropic sources of point sources of equal amplitude and spacing in broadside array, the half power beam width is given as 57.3 by L by lambda. So these are the things we need to find out for any case for a linear array or broadside array or the n-file array. So the regression of pattern maxima in the regression of 90 and 270, the regression of pattern minima we have identified as 0 degrees, 180 degrees, 60 degrees and 120 plus or minus 120 degrees. And the beam width value we have identified as 114.6 degrees by L by lambda. And the half power beam width value is identified as 57.3 by L by lambda. So these are the things necessary for us to draw the regression pattern of the broadside array. Now let us take another case, the n-file array. So if we assume theta is equal to 0 or 180, then the array to be n-file, the phase angle must be in such a way, the maximum radiation must be in the line of array. In broadside array, the elements are like this, along the line of the array. The maximum radiation will be like this. But in the n-file array, the elements are on the line of the array. So we should make the radiation pattern in such a way that the radiation pattern will be maximum along the line of the array. This is the n-file case. This is the broadside case. That means the radiation pattern is perpendicular to the line of the array in the broadside case. The radiation pattern is along the line of the array in the n-file case. So if we want to get the radiation pattern along the line of the array, so we need to make the system in such a way that the system configuration in such a way that psi must be equal to 0 and theta must be equal to 0 or 180 degrees. So under these two conditions only we can make the radiation pattern possible to drive the radiation pattern in the direction of 0 and 180. So this is 0, we know that this is 0 and 180. So the theta value is 0 and 180. right? And the psi is equal to 0. So under these two conditions, we can make the regression pattern parallel to the line of the array. So here, beta d, we know that psi is equal to beta d cos theta plus alpha. Under these two conditions, we know that psi is equal to 0 and theta is equal to 0. You will get alpha is equal to minus beta d. You will get alpha is equal to minus beta d. And what is beta? 2 pi by lambda. So overall, you will get alpha, the path difference is equal to minus 2 pi d by lambda. Minus 2 pi d by lambda. So this is beta is equal to 2 pi by lambda. See here, 2 pi d by lambda. And we know that d is equal to lambda by 2. That means the spacing between the elements is lambda by 2. If you substitute lambda by 2 here, you will get 2 pi by lambda into lambda by 4. And if you simplify, this indicates that the phase difference between the sources of an end-fire is retarded progressively by the same amount as the spacing between the sources in remains. It radians, right? So there is a retardation of progressive phase shift. Hence, we got the minus value here, right? So alpha, the phase shift we are getting as a minus value here. This minus value indicates that there is a retardation of the progressive phase shift along the progressive phase shift by the same amount as the spacing between the sources in the radians. If the spacing between the two sources is lambda by 2 or lambda by 4, then the phase angle by which the angle source 2 lags behind source C is this, right? So suppose two elements are separated by distance of lambda by 2, with how much amount of angle the phase will lag, right? So between two elements are separated by lambda by 2, with what angle the phase angle will lag. So we'll get 2 by lambda into lambda by 2. Similarly, if the distance between the separation between the two elements is lambda by 4, with what amount of phase difference phase angle source 2 will lag. That means source 2 will lag source 1 by an angle of pi by 2 radians. That is the meaning of this, right? So if these two elements are separated by distance of lambda by 2, suppose this is 1 and this is 2. These are separated by lambda by 2. These are separated by lambda by 2. If two elements are separated by 2, in end-fire case, with what amount of angle, source 2 will lag with source 1. Source 2 will lag with source 1. It means that source 1 will go faster, source 2 will go, the radiation produced by source 1, the radiation produced by source 1 is leading, the radiation produced by source 2 is lagging by an angle of 2 pi by lambda into lambda by 2. So that is the meaning of this alpha value. So alpha is equal to pi by 2. This is the case for lambda by 2. This is the case for lambda by 4 distance. Now for this end-fire case also, let us determine the direction of pattern maxima. So we know that from the basic expression of total electric field strength, the sign value will be maximum at 1. Sin n psi by 2 is equal to 1. Again, you will simplify that sin n psi by 2 is equal to the trigonometric solution is given as plus or minus 2n plus 1 into pi by 2. Further simplification, you will get psi is equal to plus or minus 2n plus 1 by n into pi. Right? So we know that the basic expression is Et is equal to sin n psi by 2 by sin psi by 2. So from this expression only, we will get the value of direction maxima when sin value is equal to 1. And we know that psi is equal to beta d cos theta plus alpha. Substitute for end-fire case, alpha is equal to minus beta d. Right? So just now we have derived alpha is equal to, the alpha is for end-fire case is minus beta d. Now substitute this alpha is equal to minus beta d here. In this case, psi is equal to beta d cos theta plus alpha. Substitute this alpha here. Right? Psi is equal to beta d cos theta plus alpha. Substitute alpha is equal to minus beta d. So now we are going to find out the maximum, minor lobe maxima. Minor lobe maxima. We are going to find out the minor lobe maxima. Plus or minus 2n plus 1 by n into pi. If you further simplify, you know that alpha minus beta d is substitute here. And if you further simplify, you will get the value of theta max here. Mathematically simplify. If you simplify, beta d into cos theta max is equal to minus 1 is equal to plus or minus 2 plus 1 by n into pi. If you further simplify, you will get cos theta max equal to plus or minus 2n plus 1 by beta nd into pi into plus 1. Now let us take a special case by taking the number of sources as 4 and d separation is lambda by 2. So cos the minor lobe maximum will be equal to cos inverse of plus or minus 2n plus 1 by beta nd into pi plus 1. Now for these conditions, let us assume n is equal to 4, number of sources are 4, whose separation of sources is given by lambda by 2 and alpha is equal to minus pi. Right? So alpha is equal to minus pi. So if you substitute alpha is equal to minus beta d, you will get minus 2 pi by lambda into what is d? Lambda by 2. So lambda get cancelled, 2 get cancelled, you will get alpha is equal to minus pi. So this is alpha is equal to minus pi. So let us find out the angle minor lobe maxima at 1. So let us assume n is equal to 1. That is, we want to find out the first null. We want to find out the first minor lobe maxima. Assume n is equal to 1. If you substitute this n is equal to 1, n is equal to 4, d is equal to lambda by 2 in this expression, you will get cos inverse of plus or minus 3 by 4 plus 1. So you will get 7 by 4 comma 1. And this 7 by 4 does not exist. Why? Because 7 by 4 means you will get 1 point something. 1 point something you will get. 7 by 4 means. So the cos value, maximum value is 1. So the 7 by 4 does not exist. You ignore this value. Now let us take only the 1 by 4 value. 1 by 4 means 0.25. You will get 75.5 degrees. Why? Because 7 by 4 does not exist. Similarly, n is equal to 2. Minor lobe second maxima. That means there might be like this. These are known as minor lobes. This is 1, this is 2. Right? So for n is equal to 2. If n is equal to 2, let us find out in which direction the second minor lobe is, in which angle. The second minor lobe is in which angle we want to find out. Substitute n is equal to 2. If n is equal to 2, again the same case, you will get plus or minus 5 by 4 plus 1. You will get minus 1 by 4, minus 75.5. Right? That means 75.5, this is the first lobe, minor lobe maxima, and minus 75.5 is the second minor lobe maxima. And similarly, the relations of pattern minima is obtained by putting alpha is equal minus beta d. Again, substitute alpha is equal minus beta d. And if you further simplify, alpha is equal minus beta d, you will get cos theta min. That is minor lobe minima. Minor lobe minima we want to find out. If you further simplify, you will get 1 minus 2 sin square theta min by 2 minus 1. So cos theta min minus 1 is equal to plus or minus 2n pi by beta nd. If you simplify this, you will get beta is equal to 2 pi by lambda. Substitute beta is 2 pi by lambda into nd into 2n pi plus or minus n lambda by nd. Plus or minus n lambda by nd. So if you further simplify here, you add 1 and minus 1 both sides. So if you further simplify this, you will get minus 2 sin square theta min by 2 plus or minus n lambda by nd. And sin square theta min by 2 is equal to plus or minus n lambda by 2 nd. And theta min, you want to find out the theta min value. So theta min is equal to 2 sin inverse of plus or minus. You will get theta min as 2 sin inverse of plus or minus 2 n lambda by 2 nd. Now pattern minima can be obtained by obtaining n is equal to 1, 2, 3. For example, if you substitute n is equal to 4, d is equal to lambda by 2 and n is equal to 1, you will get plus or minus 60 degrees. Theta min 1. That is minor lobe minima. This is the point minor lobe minima. Minor lobe minima. This is major lobe minima. This is major lobe minima. Okay. So the minor lobe minima, the direction is plus or minus 60 degrees. You substitute the values n is equal to 4, d is equal to lambda by 2, n is equal to 1. You will get theta min at the direction of plus or minus 60 degrees. Similarly, if you find out n is equal to 2, it is minor lobe minima, second one. Minor lobe minima, second point. You will get plus or minus 90 degrees. Similarly, if you find out n is equal to 3, minor lobe, third minor lobe, if you find out n is equal to 3, you will get plus or minus 120 degrees. Similarly, minor lobe minima 4, fourth one if you want to find out, fourth one, that means 1, 2, 3 and 4, 1, 2, 3, these are known as minor lobes and this is the major lobe, Right? So to find out the 4 minor lobes, find out n is equal to, substitute n is equal to 1, 2, 3 and 4. You will get in different directions what are the minor lobes. So overall, the n-fire array, you find out the n-fire array, the minima are separated in the directions of plus 60, plus 90, plus 120, plus 180 and minus 60, minus 90 and minus 120 and minus 180. So whatever the values we got just now, by substituting n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So you will get 60, 75, 90, 120, minus 60, minus 90, 180, 120, the minor lobe minima. And we also got the minor lobe maxima as 60 and 75.5. 60 and 75.5. And we know that in the n-fire case, the maximum value will be 0 and 180. That means the regression pattern, these are known as a major lobe maxima. Major lobe maxima will be 0 and 180 degrees. But minor lobe maxima are 60 and 75 degrees. And these are minor lobe minima. These are known as minor lobe minima. That means this is 90 and this is 60 here, minor lobe minima. So like this, you can identify all the direction of pattern maxima and pattern minima. And this is the special case for n-fire array to find out the beamwidth value. As seen in the broadside array, we know that the beamwidth is equal to 2 into theta 1 and the theta min is equal to 2 sin inverse of plus or minus root of 2 n lambda by 2 nd. Right? So 2 sin inverse of plus or minus root of n lambda by 2 nd. So from this, if theta min is very less, then psi theta min can be equal to theta min, that equal to 2 into plus or minus n lambda by 2 nd. If you take 2 into the square root, you will get, it becomes 4 n lambda by 2 nd. If you simplify this, you will get equation 39 as theta min is equal to plus or minus the square root of 2 n lambda by nd. Now, if we know that the length of the array is given by n minus 1 into d, if n is large, very large, the number of sources are very large, then L be equivalent to nd, small nd. So theta min is equal to plus or minus 2 n lambda by nd. Substitute this nd as L. We know that nd is equal to L. So plus or minus 2 n lambda by L. Now beamwidth, we know that 2 into theta min. Beamwidth is taken as 2 into theta min. So 2 into theta min means substitute the value of theta min in this expression, that is, this is theta min. Right? So plus or minus 2 n lambda by nd. If you further simplify this, you will get 2 theta 1 is equal to root of 2 n by L by lambda. Now if you want to find out the n is equal to 1, if you substitute n is equal to 1, that is a major lobe maxima. Suppose the major lobe maxima, the value of n is equal to 1, then plus or minus you will get beamwidth with first terms is equal to 2 into square root of 2 by L by lambda. So if you further simplify, you will get beamwidth with first terms as 114.6 into root of 2 by L by lambda. If you want to find out the half power beamwidth, so this is nothing but BWFN by 2. Half power beamwidth is equal to BWFN by 2. This is equal to 114.6 by divided by 2 you will get. Right? So this is how to find out the beamwidth with the first terms, half power beamwidth of n isotropic point sources of broadside array and also the n-fire array. So with this we will close the session today and we will continue in the next session the remaining topics of the course of array. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.